In the last section, when we constructed the strings for n equals 2, we used the process of elimination, checking all possible strings against the rules and removing those strings that were not valid. This time, we'll explain the results for n equals 3 using a more strategic approach. First, notice that strings that start with a 0 will always have initial segments with more zeros than ones, which violates Rule 2. We mentioned this in the last lesson, but strings ending in a 1 also break Rule 2, because by Rule 1 we have equal numbers of zeros and ones, and when we use up a 1 in the last position, then the string prior to that 1 will always have more zeros than ones. These observations allow us to use a template for valid strings that begins with 1 and ends with a 0. Now look at the second position. It could either be 1 or 0, and the string would still obey both rules. Let's set it to 1 and move on to the third position, which also could be a 1 or a 0 and still be valid. If it is a 1, then we've used up our 3 ones, and by Rule 1, the rest of the string will be zeros. Bingo! First valid string found. 111000. Backing up a step, let's change the third position to a 0 and see what our choices are. If we put a 1 in the fourth position, we again have used up all our ones, and a 0 would go in the fifth position. So 110100 is the next valid string. If instead we chose another 0 in the fourth position, we would have used up all 3 zeros, and the fifth position can only be a 1, making our next valid string 110010. Now to see our remaining options, let's go all the way back to the second position and change it to a 0. Rule 2 now forces a 1 in the third position, leaving us either 1 or 0 in the fourth position. We choose 1, and again, this is the third one, so the rest of the string is zeros, making 101100 the fourth valid string. And finally, choosing 0 in the fourth position means all the zeros are used and only a 1 can go in the fifth position, 101010. These are the only possibilities for n equals 3. As you might have guessed, our game has had a more serious purpose than just finding valid strings of ones and zeros. It turns out that you can interpret the Catalan series as the count of the number of strings we have generated for each successive value of n. So, at this point, the Catalan numbers are 1125 for n equals 0, 1, 2, 3. Can you predict the next Catalan number in the series 1125? In other words, the number of strings for n equals 4. The verb named test4 will guide your search.